Buongiorno a tutti, direi che ci siamo, una grandissima parte degli iscritti sono affluiti al webinar in questo momento. Il mio nome è Alessandro Magrin, lavoro per la Orion SRL di Veggiano, sono un sales manager e anche specialista di linea di prodotto per quanto riguarda la linea Occupational Health and Safety, ovvero igiene e sicurezza industriale della linea della compagnia Orion SRL, della quale vi do una brevissima introduzione e una veloce infarinatura in modo che sappiate di che cosa tratta la nostra realtà. La Orion SRL inizia la sua storia esattamente 35 anni fa dalla volontà della famiglia Solmi, che si posiziona in un ramo di mercato che ha a che vedere, che ha a che sviluppare il monitoraggio ambientale. L'azienda cresce velocemente negli anni ed oggi siamo una realtà che definisce e persegue l'obiettivo di affermarsi quale società punto di riferimento per quanto riguarda tutto ciò che ha a che fare con l'industria e l'ecologia, e soprattutto in particolare il monitoraggio dell'aria, dell'acqua, delle emissioni industriali, del monitoraggio degli odori e come introdotto all'inizio anche la possibilità di sviluppare un vero e proprio settore di igiene e sicurezza industriale con una gamma di prodotti dedicati ad esso. È una società multilivello ed è ormai di alta competenza sia sul territorio nazionale italiano sia su molti stati esteri sui quali abbiamo portato a termine grossi progetti. Ci occupiamo di analizzatori, sistemi integrati, analizzatori e soluzioni per il monitoraggio, analizzatori e soluzioni per il monitoraggio delle emissioni fuggitive, analizzatori e sistemi integrati per il monitoraggio della qualità delle acque, strumenti per il monitoraggio delle emissioni o d'origine e ricerca e sviluppo per il monitoraggio indoor e outdoor che ha a che fare con igiene e sicurezza industriale. Vado un po' veloce in queste slide che ripetono quello che ho già annunciato precedentemente. Sottolineo solo che siamo presenti in tutto il territorio nazionale con servizi tecnici in situ, anche fissi su grossi impianti industriali che prevedono appunto una manutenzione H24. Siamo certificati negli anni con molti step, molti scatti in avanti in tutte le uni che sono descritte in questa slide, fino ad arrivare all'ultima del 2022, etica SA 8000. Siamo accreditati anche per laboratori di taratura gas dallo scorso anno. Abbiamo un centro ricerche sviluppato nella nostra filiale a Pastorano, nel sud, e, come dicevo, siamo posizionati e dislocati in tutto il territorio nazionale. Quello che ha a che fare con me principalmente è l'igiene e sicurezza industriale, il quale ci appoggiamo per la maggiore all'azienda TSI, che sviluppa tutta una serie di prodotti che hanno a che vedere appunto con il monitoraggio e la sicurezza degli ambienti di lavoro. Oggi punta di diamante è il PortaCount Field Tester, di cui ci parlerà ampiamente la Giannina Sander, che è la specialista di prodotto e della linea Health and Safety della TSI. Premetto che durante la sua presentazione ci sarà la chat aperta, potrete scrivere domande alle quali io risponderò. Poi verso la fine, nella sezione domande e risposte, sarà aperto anche il microfono e si potrà parlare e liberamente interloquire tra di noi. Passo la palla a Rolando Winkel. I introduce Rolando Winkel.
Buongiorno.
The Southern Europe Sales Manager della TSI, che darà, come l'ho data io, una breve introduzione della TSI e poi sentiremo parlare degli argomenti che attendiamo per questo webinar.
Buongiorno, my name is Rolando. As Alessandro just said, I'm the sales manager of Southern Europe for test and measurement. Test and measurement is only a part of TSI. You will see, I will show you now the presentation, and you could appreciate how wide our offering is. Just 1 second, let me find this master operation. Okay, and of course, Orion in my territory, Italy is one of the important countries, and Orion is one of our most successful distributors in the region. And thank you, Alessandro, for your good work. And thank you, Alicia, as well, and the whole Orion team. So can you see the full picture, the full presentation? Can you see something now?
Yes.
Okay.
Yes.
So you don't see, you need to see me now. Okay, so this will be very, very fast, so we can go into today's topic. And about just a word about TSI. We're a company founded just more than 60 years ago now. Yeah, in 1961 in Minnesota. So this is where our headquarters are, in Shoreview, and we are pioneers in the area of aerosols and other instruments, as you will see. This is a privately held company, and we have a couple of sisters companies as well. We are all, I would say, all over the world, but as I said, headquartered in the US and main offices in Europe, in UK, in Germany. You have an office in France and also in Asia as well, India. So those are the main headquarters, but we are present all over the world through our good distributors as Orion. Customers are all over, any area that you can mention, that you can think of, any sector of activity, any market. We always have an instrument suitable for the activity. For instance, manufacturing, we are there. We are in environmental. We'll talk a lot today about, we'll talk mainly about fit testing, but in the second part, we'll have an overview of environmental as well. We're present in healthcare and medical. We have famous good instruments as flow meters that are in those areas. We are also known in the HVAC and IAQ. So this is heating, ventilation, and air conditioning. And we have some flagship instruments here that you can see, like velocicalcs for air velocity, and dust trucks that we will talk a little bit today as well. So present in health and safety. In research, you see also already the difference between the blue instruments of our range, my range of TNM, and also Alessandro's, and some of our colleagues, which are more of the lab type of research and analytic. We are present in every field, as I said, with the importance of aerosols and controlling the quality of the air. When you manufacture a silicon wafer, for instance, you need to be sure that it is extremely clean atmosphere. And our instruments are used in those areas as well. So critical environments, pharma, manufacturing, agriculture. This is our sister company. Dickie Jones will not talk about that today. And that's for the very fast introduction. And handing back now, or handing it to Janina, please.
Yes, thank you, Rolando. I'm start sharing my screen. And I also already read the question within the chat. Yes, my part will be in English language because unfortunately I'm not able to speak Italian that you could understand me. But you are able, if you have any questions concerning understanding, just ask the question in Italian into the chat and Alessandro will answer them. And yeah, if I'm speaking too fast, just make a note in the chat and Alessandro will stop me that I'm reduce my speed and everyone hopefully can follow me. So yes, I will talk a bit. I will talk about particle as health and safety concern as the first part. Quite short myself. My name is Janina Sander, as Alessandro introduced me. I'm working for TSI as the application specialist for our health and safety instruments in Europe, Middle East, and Africa. In the first presentation, I would like to give some introduction things like important definitions, something about particle properties, why are particles interesting, and also about respiratory protection, of course, because this is what we want to talk about. And yeah, starting with the important definitions. If we talk about protection from respirators, we have to understand why are we wearing respirators and how and why are they protecting us. And therefore, we first have to understand for what they are protecting us. And if we are looking at particles, for example, we are using this word as one word for everything because there's not the one particle. Particle, per definition, is every small object that can be localized and that can be attributed by several physical or chemical properties like mass, density, volume, etc. So there can be multiple different forms of particles, just an example here. And particles are also varying greatly in size or quantity. So as you can see with the other forms here, so there's the need of redefinition by every scientific field that's handling with particles. So this is just one example talking about subatomic, microscopic or macroscopic particles. Just one example, everyone needs its own definition. Then we often hear in occupational health and safety the term particulate matter. And this by origin from the word just mean particulate is the state of everything that contains of particles. But in a common use, particulate matter is used as a noun for describing pollutants in the air. And the very important thing here is that particulate matter includes all fine microscopic solid particles and or liquid droplets that are suspended in the air. So it's not just about solid particles, but the combination of solid particles and liquid droplets. Other terms you might heard would be atmospheric aerosol particles or suspended particulate matter, atmospheric particulate matter, or just PM. And there's the small difference to dust. When we're talking about dust in the air, it's just the solid particles, while particulate matter is solid and liquid. The third definition I would like to give you is the aerosol. So what's an aerosol? Aerosol is the mixture of air and particulates. So the aerosol is the mixture of aerosol particles, so liquid or solid, and a gas. Normally, it's the mixture of gases we do have in our breathing air. So aerosols can be naturally occurring or man-made, like fog or dust, also naturally or man-made occurring. It can be fumes and smoke. And also, I think we know that since COVID, also the air we are breathing out is an aerosol, which contains particles, solid and liquid. Okay, so this would be the first definitions. What is the important thing about particles? And I would like to introduce some particle properties. And first, I would like to take a look at different types of particles and droplets. And you see here, I hope you can see it here, the particle size at the x-axis in a logarithmic scale. So we are here from 100 micrometer down to 1 nanometer, so very, very small. And you see, for example, what happens in industry, what you can find is welding fume, and welding fume consists of particles and droplets in this very broad size range, so from 1 nanometer to 100 micrometer, very big to very small, while you can see, for example, windblown dust is more the bigger particles, while we have diesel engine exhaust, more in the range of the smaller particles. Just an example. So why is the size at all significant? Why are we interested in? And I want to show you this example here for 1 millimeter, because I think everyone agrees that 1 millimeter is quite small. 1 millimeter is the same as 1,000 micrometers. And if we're comparing the 1,000 micrometers to a human hair, this has an average diameter of 60 micrometer. This is in true scale to the 1 millimeter, so much smaller. And you see here this blue bubbles, the blue particles, these blue ones are 10 micrometer in size, so they would fit into the category of PM10, so dust and pollen. And if we make it a little bit bigger, you see in true scale on the blue one, the green ones. And the green ones are a size of 2.5 micrometer. That could, for example, be bacteria. And on this green one, you see this very small yellow one, and this is a PM1, and this could be so smaller 1 micrometer. That could be, for example, in the categories of viruses. And why is this size interesting for us? Because the particle size decides how deep we can inhale the particles. The PM10 particles, they are called also respirable dust, even if it's not only dust, but also liquid droplets. We can inhale them, but they normally just reach our nose and throat and mouth. The smaller particles, the respirable particulate matter, in the size of PM4, so everything smaller than 4 micrometer, can already reach our lungs. So this is why they are called respirable. And the even smaller ones, PM2.5, they can also reach our deepest lungs, and the PM1 particles can also be part in the blood exchange and the gas exchange in the lungs, so they can reach our bloodstream and can be distributed through the whole body. With that, I want to come back to the 1 millimeter as an example. So we said 1 millimeter is quite small, but if we now draw into that line of 1 millimeter some PM10 and PM2.5 particles, you see there fits a lot of these particles in this 1 millimeter. So just showing they are very, very small. What are the effects of particulates and aerosols in this term? We have effects on the human health and also on the environment. On the human health, we can differentiate between short-term and long-term. Short-term would be something like coughing or wheezing to get the particles out again. But long-term would be something like asthma, diabetes, cardiovascular diseases, cancer, and also cognitive impairment, because the very, very small particles can also reach our brain. In the environment, particles can be carried over long distance, so they are influencing different ecosystems. So, for example, particulate matters can enter aquatic ecosystems, like the most known example of microplastics in fishes, and also it can change pH level of different water systems, and therefore it can be lethal for certain organisms. Also, PM interferes with the vegetation, as the particles can block stomature and lowers therefore the CO2 absorption, for example, of trees. And therefore we find some tolerant species that can thrive and dominate afterwards. So the balance is changed there. Okay, with that, some basic things about particles. We came to the most important topic for today, the respiratory protection. And I want to give you an introduction of the different categories of respiratory protection. At first hand, you can make two groups in the group of respiratory protective devices, the air purifying devices or filtering devices, and the air supplying devices. The air purifying devices are using the ambient air, and they are just air purifying the air, or they are powered air purifying respirators. In the category of air supplying respirators, we do find the supplied air respirators and the self-contained breathing apparatus, SCBAs. We will take a detailed look on it, and starting with the air purifying respirators. The air purifying respirators are filtering the ambient air. This is why you also sometimes hear the word filtering respirators or respiratory protection. So they are using the very dirty ambient air we can see on that side, breathing through the filter and have a cleaner inhalation air. But what you can also see here on the picture, that it's not 100% clean, that it's just a specific percentage that it's cleaned out through the filter. And the most common example, I think, through the last years are the negative pressure tight-fitting mask, like FFP mask filtering face pieces. On the hand of the powered version, there can be there's like a pump that you're wearing on your hips, for example, and they are soaking in the ambient air and pumping it through a filter and then pumping the cleaned air into a tight-fitting mask or into a loose-fitting hood. So this is the side of air purifying respirators. Now taking a look at the air supplying respirators. And the supplied air respirators can be the normal supplied air respirators, can be also with a tight-fitting mask. And there we are not using the ambient air, but we are using breathing air out of some kind of supply. I just draw a bottle here. Normally it would be some stationary tubes inside the industrial hall. This can be also be worn as a tight-fitting mask or as a loose-fitting hood. And then there are the self-contained breathing apparatus. Here you see you definitely have your bottle that you're wearing on your back and carrying with you that supplies the breathing air either in a tight-fitting mask or in a loose-fitting hood. Okay, so what you could differentiate this one is the negative and positive pressure. If we take a look at them, you see that only the air purifier respirators, so where we actively have to breathe through the filter, are so-called negative pressure respirators, while all others, where we have some kind of pump or flow of air, they are called positive pressure masks. We can also differentiate between the so-called open respiratory interfaces and the closed respiratory interfaces. What does that mean? The closed respiratory interfaces are defined as having a defined ceiling line. So to the open respiratory interfaces are like hoods and helmets, and the closed respiratory interfaces are the masks, like the full face mask or the quarter and half face masks. The full face masks have their ceiling line over the forehead, cheeks, and below the chin. The half face masks have their ceiling line over the bridge of the nose, cheeks, and below the chin, and the quarter face masks, not that often used, over the bridge of the nose, cheeks, and above the chin. Okay, let's take a look at the closed respiratory interfaces, because they are the only ones who are important for fit testing, because it's fit testing of tight-fitting respirators. If we take a look at tight-fitting mask and negative pressure, so the FFP mask or the typical half-face or full-face mask, then we do have our dirty ambient air breathing through the filter material and having cleaned air within our breathing zone inside the mask if the mask is well fitting. If the mask does not fit, so if it's poor fitting, we do have leakages, like just an example below the chin or above the nose. And having these leakages means that we are breathing not through the filter of the mask, but through the leakages, because air always takes the way of least resistance. And a filter material, as we all remember, wearing masks through COVID, there's a breathing resistance. And in the leakages, there's not. So we are inhaling the air through the leakages, and as we are breathing around the mask instead of through the mask, we of course inhaling all the dirty air, which is then also inside the mask. So with this negative pressure mask, the filtration is our single protective function of this respirator. And to get the filtration, we do need, of course, a high filter quality, but also the tight fit that we are really using the filter quality. In positive pressure masks, like this one's, it's a bit different. If we have a well-fitting mask and a working air supply, we have our dirty ambient air and a cleaned breathing air. If our mask is poor fitting, but the air supply is working, it's the same situation because we do have positive pressure and the air is floating out of the mask through the leakages. But if for some reason our air supply is broken, it's completely out or it's too less or whatever, then we do have the same situation as with a negative mask. As the overpressure is not big enough, we are again inhaling through the leakages as there's less resistance for the air, and we do find all our hazardous substances also inside the mask. So with this tight fitting mask and positive pressure, we do have two protective functions. The first one is the positive pressure, and the second one is the tight fit. Then you might wonder, yes, but I am only using respirators that has a CE mark. And I now show you the process. When there's the mask manufacturer manufacturing the mask, they are getting like a product certification. This is the CE mark. Afterwards, the employers are purchasing and choosing the respirators. The employees are wearing the respirators, and the protection is thus just a question mark because the CE marking uses face characteristics of a so-called typical user. So they are sorting out test subjects who do not fit the respirator. While if we are looking at the wearing size, no one of us has a CE marked face, and I'm quite sure that no one of us has a European standard head form. So we have, for example, different sizes of the same mask model, but the same CE marking. Some of us might have missing teeth, others might have scars within their face, and we all don and adjust our mask differently on our face. So if we, behind this wearing process, put the fit test, or better before, we can reduce this question marks in terms of not fitting between CE marking and really using the respirator, and we can bring our protection to a maximum. The next interesting point in terms of respirators are beard hairs. So I think that's the typical everyone who is working in health and safety with people working with respirators, beards is always a topic. And I want just to take an example of a stubble, so a single hair that is between the face and the mask. And here again, the diameter of 60 micrometers. And I just draw it into these tiny holes that are then existing between mask and face, some of the 10 micrometer, 2.5 micrometer, and 1 micrometer particles. And you do see there fits lots of them into this tiny little leakages. And if we have a full beard, so the hair's like building a layer of hair and air between face and mask, you do see that I even wasn't able to draw the 1 micrometer particles because PowerPoint wasn't able to let us show this very small points. So you just can see here 10 micrometer and 2.5 micrometer particles, and you see that there's lots of them, and you have to imagine that all of them are potentially dangerous for your health if you're wearing a respirator. So some example of beards, because the important thing with masks is that not that the beard in general is a problem, but that there is no hair in the ceiling area of the mask. So you always have to check which is the ceiling line of my mask and how is the beard of this specific person. So one example, if we take a look at a half face mask, so this should be this white line, should be the ceiling line of a half face mask. You do see that the first row, the 3 beards are no problem because there's no hair in the ceiling line. The first 2 in the second line are critical because you see you definitely have to take a look at the individual person if the beard is interacting in the ceiling area or not. And the others are definitely prohibited because there's hair in the ceiling area and the beard's interfering with the mask fit. Okay, with that, this was the first presentation, and I think I'm ending the presentation right now because I started to explain a little bit the technical side of why, from a technical point, fit is a very important topic. And Mr. Marco will now introduce to you the legal situation, so why, from a legal standpoint, the fit is also quite important, and we have to talk about fit testing.
Grazie Gianina, buongiorno a tutti e ora parleremo di quello che è l'aspetto, diciamo così, legato alla normativa italiana. Si vedono le slide, sì?
Sì.
Ok, perfetto, grazie. Allora, parliamo appunto di quello che è l'aspetto della normativa italiana e quindi per analizzare la normativa vigente in materia di apparecchi per la protezione delle vie respiratorie dobbiamo partire dal testo unico per la salute e sicurezza sul lavoro, che al capo secondo riporta gli articoli specifici che riguardano i DPI. Faccio una piccola premessa attaccandomi anche a quello che ha detto Gianina poco fa sul discorso dei dispositivi di protezione individuali, secondo la normativa europea, quindi la marcatura. Noi abbiamo quelli che consideriamo DPI di prima categoria, ovvero di progettazione semplice, di cui il progettista presuppone che l'utilizzatore possa giudicare il livello di protezione contro i rischi minimi e possono essere questi rischi tranquillamente avvertiti in tempo utile, senza recare danni all'utilizzatore. Appartengono quindi a questa categoria i DPI destinati a proteggere chi li indossa contro le aggressioni meccaniche con effetti superficiali, i guanti da giardinaggio, i ditali per cucire, i prodotti per la pulizia, la cui aggressione sia di lieve entità e facilmente reversibile, eccetera, eccetera, eccetera. Abbiamo poi, secondo la classificazione del regolamento europeo, invece i DPI di terza categoria, che sono quelli di progettazione complessa e rientrano in questa categoria i dispositivi di protezione respiratoria filtranti contro gli aerosol solidi, liquidi o contro i gas irritanti, pericolosi, tossici o radiotossici. Quindi gli apparecchi di protezione respiratoria che isolano completamente dall'atmosfera, inclusi quelli destinati all'immersione. Quindi i DPI assicurano una protezione limitata nel tempo contro le aggressioni chimiche o le radiazioni ionizzanti, i dispositivi di protezione individuale contro le alte temperature oltre i 50 gradi, tutto ciò che è, diciamo, protettivo nei confronti della vita, della salute della persona. E poi abbiamo i DPI
non sento più nulla, si è bloccato tutto.
Credo che abbiamo un attimo perso la comunicazione con Marco.
Sì, ok.
Attendiamo un secondo. Stava facendoci la panoramica sulla tipologia
Confermo.
di categoria, infatti è bloccato il suo video. Attendiamo un attimo, magari è lui che riesce a risolvere la cosa, perché sicuramente è la sua linea. Visto che siamo tutti collegati, deve essere un problema legato a lui. Vediamo se ci dà qualche segnale, intanto provo a chiamarlo.
Rieccomi, scusate, è caduta la linea. Mi sentite? Vedete la presentazione? Sì? Ok.
Sì.
È andata via la corrente. Quindi dicevo, Seconda categoria, tutto ciò che non è prima, tutto ciò che non è terza categoria. Quindi, quando parliamo di terza categoria di APVR, fanno parte i respiratori isolanti, i dispositivi per la fuga, gli elettroventilatori e le semimaschere, le maschere pienofacciali e i facciali filtranti. Tutti questi sono DPI di terza categoria e rientrano tutti nel regolamento europeo. Tornando quindi alla norma, alla legislazione specifica, con l'entrata in vigore della legge 215 del 2021, che è stata pubblicata nella Gazzetta Ufficiale al 20 dicembre 2021, è stato convertito in legge il decreto 146, che ha apportato alcune modifiche in tema di salute e sicurezza. Tutti voi probabilmente l'avete sentito nominare, se ne è parlato tanto negli anni passati, il ruolo del preposto, la formazione e l'addestramento anche per il datore di lavoro, i provvedimenti di sospensione dell'attività, eccetera, eccetera. Quello che più ci interessa è la modifica che è stata portata all'81 per quanto riguarda i criteri e l'individuazione nell'uso dei DPI. Quindi la modifica dell'articolo 79 che individua i criteri per la scelta e per l'uso dei DPI e nello specifico al comma 2 bis recita: fino all'adozione del decreto di cui al comma 2, ovvero fino a quando il Ministero, di concerto con la Commissione consultiva permanente, non promulgheranno un idoneo documento nel quale si identificano i criteri per l'individuazione e l'uso dei DPI, oltre alle circostanze e situazioni in cui impiegare i DPI, restano quindi in vigore le indicazioni del decreto del 2 maggio del 2001 con le norme uni più recenti. Quando parliamo quindi di decreto del 2 maggio 2001, andiamo a individuare un decreto che era stato predisposto nel quale si definivano i criteri per l'individuazione e l'uso dei DPI e nell'allegato unico, allegato 1, scusate, specifico per gli ortoprotettori, mentre l'allegato 2 specifico per gli APVR, quindi gli apparecchi di protezione delle vie respiratorie. Poi ci sono l'allegato 3 che individua i filtri per le saldature e le tecniche connesse, i filtri ultravioletti, e l'allegato 4 per gli indumenti protettivi. Questo è il DM del 2001. Nell'allegato 2, se andiamo a leggerlo nello specifico, il DM riportava la norma UNI 10.720 del 1998, che era la norma che portava alla guida e alla scelta all'uso di apparecchi di protezione delle vie respiratorie. Questa norma è stata poi sostituita e aggiornata con la UNI EN 529 del 2006, che in Italia ha portato la redazione della UNI 11.719 del 2018. Se fate caso, nei campi d'azione della 529 si individua una buona pratica, mentre nella 11.719 si definisce uno strumento per il programma di gestione degli APVR. Quindi, riassumendo, il decreto 8108 ci parla nell'uso dei DPI, nello specifico l'articolo 79 dice che dobbiamo attendere un decreto ministeriale che dovrà uscire, nel quale si identificheranno i criteri di scelta e uso dei DPI. Ma fino a quando non uscirà, al DM del 2001 e alle norme UNI più recenti, ovvero la 529 che è stata in Italia aggiornata con la 11.719 del 2018. Vi do anche un'anteprima: entro fine anno uscirà un aggiornamento ulteriore della 11.719. Quindi quando parliamo della norma 11.719, la norma ci, diciamo così, identifica una serie di attività che cadono in capo al datore di lavoro, quindi all'azienda, per quanto riguarda la scelta dei corretti di DPI, nello specifico delle APVR. E quando parliamo di obblighi nei confronti del datore di lavoro, il principale obbligo è quello del creare un programma di protezione delle vie respiratorie, nel quale identifica i criteri che ha utilizzato per la scelta, nel quale individua gli APVR adeguati, definisce le modalità d'uso e di manutenzione, definisce come gestire, immagazzinare, trasportare, conservare l'APVR e definisce la prova di adattabilità dei facciali per ogni singola persona. Quindi, quando parliamo del programma, è logico che il datore di lavoro dovrà individuare dei ruoli e delle responsabilità, chi fa che cosa. Dovrà elaborare quindi un registro nel quale individuerà tutte le azioni che devono essere fatte nei confronti degli APVR, quindi della gestione degli stessi dispositivi. Dovrà individuare quali sono i migliori APVR per la propria attività e quindi per i propri dipendenti, determinarne l'adeguatezza e definire programma e addestramento all'uso corretto degli APVR, perché vi ricordo, stiamo parlando di dispositivi di terza categoria per il quale è prevista l'informazione, la formazione e l'addestramento. Dovrà poi prevedere la manutenzione e l'immagazzinamento degli stessi. Quindi, venendo a noi, ha un obbligo il datore di lavoro, che è quello, oltre a tutti quelli appunto appena descritti secondo la norma, ha l'obbligo di determinare l'adeguatezza e l'idoneità della PVR, quindi il famoso fit test. Quando parliamo, come ha accennato prima anche Gianina, un facciale a tenuta, che sia un quarto di maschera, che sia una semimaschera, una maschera intera o una semimaschera filtrante, fornisce la protezione stimata solo se assicurata la tenuta sul viso. E quindi è possibile che una sola misura o modello non si adatti a tutti i portatori, a tutti i dipendenti. La valutazione quindi del corretto adattamento è una parte fondamentale del processo di selezione. Quando parliamo del fit test dobbiamo pensare che attraverso questa prova si può verificare che vi sia la tenuta tra il dispositivo e il viso del portatore. Quindi i dispositivi ermetici funzionano solo se vi è una tenuta efficace. E oltretutto la validazione del test dà delle garanzie al portatore di indossare efficacemente il dispositivo e quindi di essere protetto e dà anche garanzie al datore di lavoro per la verifica che ogni singolo lavoratore sia in grado di utilizzare correttamente il dispositivo assegnatogli. La norma prevede che vi sia un'idoneità specifica rilasciata dal medico competente all'uso degli APVR e i lavoratori devono essere formati all'uso del dispositivo prima della prova, quindi prima del fit test. Infatti l'istruzione per una corretta vestizione deve avvenire prima o comunque precedentemente all'esecuzione del fit test perché il lavoratore deve dimostrare di conoscere come indossare correttamente il dispositivo per poter essere testato e quindi verificare il fit testing, quindi verificare l'effettiva isolamento, l'effettiva ermeticità del dispositivo. Come accennava Gianina, ci sono una serie di interferenze che possono essere i peli della barba stessa, possono essere i capelli, possono essere gli occhiali, che siano DPI o che siano occhiali a vista. Anche le creme e i cosmetici possono interferire con la tenuta del dispositivo stesso. Per non parlare poi di piercing o altri diciamo ammennicoli che possono essere di moda. Anche i DPI possono interferire con la tenuta del dispositivo. Pensiamo a degli autoprotettori o dei sovrocchiali che vanno ad appoggiarsi nella zona dove il dispositivo deve fare tenuta. Abbiamo poi quelli che possono essere dei difetti legati al viso della persona, quindi presenza di cicatrici, presenza di diciamo non continuità della pelle, piuttosto anche potrebbe essere problematica la presenza di dentiere o qualcosa che può modificare il viso della persona. Parlando di frequenza, è obbligatorio effettuare la prova di adattabilità, quindi il fit test ad ogni cambio respiratore, cambio per taglia, per modello, per marca. È obbligatoria almeno ogni 3 anni per quanto riguarda l'Italia. Considerate che in altre nazioni l'obbligatorietà è annuale. E ancora la frequenza deve essere rifatto la prova di adattabilità ad ogni variazione significativa, per esempio della persona, del peso corporeo della persona. Una persona aumenta notevolmente di peso, quindi la faccia può diventare più grande, o al contrario il dimagrimento potrebbe portare a un non corretto adeguatezza del dispositivo. Se vi sono appunto alterazioni del viso, protesi dentarie, o se vi è anche un disagio nell'indossamento. Quindi se si lamenta una difficoltà a indossare, è necessario rivedere la prova di adattabilità. I respiratori logicamente devono essere puliti e disinfettati prima di essere indossati dalle persone. I respiratori utilizzati per il fit test devono essere dotati di adattatori appropriati a secondo del metodo di fit test selezionato, e dobbiamo utilizzare il respiratore che è stato assegnato alla persona, o al massimo un surrogato, logicamente garantendo la pulizia tra un test e l'altro. Deve essere fatta, il fit test deve essere fatto tenendo in considerazione un elevato grado di pulizia e igiene, e i dispositivi devono essere correttamente ispezionati, e vi deve essere poi una disinfezione alla fine del test per evitare problemi di contaminazione tra le persone. Prima di definire il miglior APVR, o quello che può essere adattato, ricordiamoci che ognuno di noi ha un viso completamente differente, sia per forma che per dimensioni. Quindi il pensare di utilizzare un unico modello, un'unica taglia per tutti i nostri lavoratori non ha senso, perché logicamente è come le scarpe, non possiamo comprare il 42 di piede per tutti i lavoratori e pretendere che vada bene a tutti. Quindi dobbiamo selezionare il dispositivo nel miglior modo possibile. Logicamente il dispositivo viene influenzato da diversi fattori, dal comfort, dalla resistenza respiratoria, dalla compromissione della vista, quindi la capacità di vedere anche lateralmente, difficoltà di comunicazione, peso stesso. Sono tutte cose che dobbiamo tenere in conto quando scegliamo il dispositivo per i lavoratori. E c'è anche la questione del comfort, come accennavo prima. Il dispositivo deve essere confortevole per il lavoratore, e tendenzialmente prima della prova del fit test deve essere indossato per 4-5 minuti dal lavoratore per appunto verificare questo comfort, per evitare poi situazioni come abbiamo visto sui media di dispositivi che non erano proprio confortevoli indosso alle persone. Quando parliamo poi dell'esito del fit test, deve essere rilasciato secondo la norma un rapporto di prova che deve contenere una serie di informazioni. Informazioni che sono essenziali per dare validità al test stesso, dal nominativo di chi fa il fit test, nel senso di chi, il portatore, colui al quale viene fatto il fit test, il fabbricante, il modello della APVR utilizzato, la data di preparazione eventualmente dell'agente di prova se è utilizzato il fit test qualitativo, piuttosto che la concentrazione ambientale, cioè tutte le informazioni che servono per validare la prova effettuata nei confronti del lavoratore. Infine ci deve essere il nominativo, l'azienda e la firma del tecnico che esegue il fit test, perché è responsabile di tutte le informazioni che vengono registrate, quindi della veridicità del test stesso. Generalmente quando facciamo il fit test è preferibile appunto che ci sia un dispositivo personale, in modo tale che il lavoratore testi quello che dovrà utilizzare o che sta utilizzando durante l'attività lavorativa. Se sono utilizzati più dispositivi, quindi una volta utilizzo la semimaschera per fare un'attività, una volta utilizzo un pieno facciale per fare un'altra attività, ho l'obbligo di testare entrambi i dispositivi. Quindi il fit test deve essere fatto per ogni dispositivo. Quando prima di iniziare il fit test la persona deve essere informata sullo scopo e sulle procedure del test stesso, deve essere fornita una descrizione di quello che dovrà andare a fare. Tutti i fit test hanno degli esercizi e quindi devono essere descritti e deve essere verificato che la persona abbia capito quali sono le modalità e lo scopo del test stesso. Quando parliamo di fit test dobbiamo quindi considerare il facciale a tenuta che il facciale a tenuta fornisce una protezione stimata solo se assicurata la tenuta sul viso, e quindi, come dicevamo prima, una sola misura o modello non può adattarsi a tutti i portatori. La valutazione dell'adattabilità quindi è una parte fondamentale del processo di selezione ed uso del dispositivo. Accennavo prima, il fit test si divide in fit test qualitativo o fit test quantitativo. Sono metodi approvati a livello internazionale e standardizzati, nel quale nel fit test qualitativo si ha è una prova del tipo passa non passa, mentre nel fit test quantitativo è una prova con un valore numerico, cioè delle attrezzature, degli strumenti determinano il valore di fit factor. Se superato vuol dire che c'è un'effettiva efficacia nel dispositivo nei confronti della persona. Vedevo prima nella chat che chiedeva qualcuno chi può fare il fit test, e anche qua è un aspetto legato alle norme, legato a quello che è la parte, diciamo così, legislativa. Nell'ambito della norma si parla di persona competente, quindi qualcuno che che viene individuato, che è responsabile di questa attività e quindi deve essere in qualche modo autorizzato. Può essere l'RSIP, può essere il preposto, può essere il medico competente, l'infermiere. Non è definito il ruolo, cioè la figura, è definita però la capacità della persona, quindi la competenza della persona. Nello specifico la ISO 16975 che parla appunto dei dispositivi di protezione delle vie respiratorie, e nella parte terza parla delle procedure del controllo di idoneità, quindi parla di tutti i fit test che sono riconosciuti, definisce questa norma, quindi quali sono sia i metodi da utilizzare quali sono le competenze che deve avere anche il fit tester. Quindi quando parliamo di competenze dobbiamo guardare appunto questa norma internazionale che definisce l'operatore competente una persona con un'esperienza adeguata e sufficiente e con conoscenze pratiche e teoriche dei metodi di fit test, che sa quindi condurre queste procedure, questa metodologia. È obbligo per l'amministratore del programma di gestione per gli APVR, che è il responsabile all'interno dell'azienda della gestione di tutti gli apparecchi di protezione delle vie respiratorie, è obbligo in questo caso la scelta deve cadere su una persona che abbia questi requisiti per qualificare la persona che fa il fit test. Quindi, secondo la norma ISO, il lavoratore, cioè il fit tester, deve conoscere gli APVR, deve saper identificare i componenti, le parti che compongono l'APVR e le loro funzioni, deve dimostrare di saper ispezionare, di saper mantenere correttamente l'APVR, deve saper riconoscere marche, modelli e dimensioni degli APVR, deve essere in grado di definire, di discutere delle capacità e i limiti stessi del singolo APVR nei confronti del test di adattamento, deve quindi valutare le procedure per l'effettuazione del fit test, compreso quello che viene definita vestizione e svestizione del dispositivo. Quindi deve avere conoscenza dei vari metodi di fit test e avere la capacità di spiegare le procedure, di spiegare le modalità del fit test, saper identificare i valori errati, quindi saper leggere se ci sono delle anomalie e saper conoscere i rischi nei confronti delle sostanze, delle attrezzature utilizzate. Abbiamo poi la capacità di impostare e monitorare il funzionamento dell'attrezzatura. Alcuni fit test, come accennavo prima, sono test che vengono fatti attraverso appunto degli strumenti, e questi strumenti hanno dei setting preimpostati, ma il fit tester deve saper conoscere e definire questi parametri. Deve logicamente individuare quali sono i filtri corretti per ogni APVR che deve essere testato, deve di conseguenza preparare e ispezionare i dispositivi, effettuare il corretto assemblaggio dello strumento, collegandolo in modo corretto al dispositivo, quindi a secondo del test che viene scelto. Deve saper inserire sonde, per esempio, con il metodo del contaparticelle, piuttosto che deve saper identificare se vi sono problemi con l'attrezzatura. Deve logicamente dimostrare di saper condurre il test valutando se la persona sottoposta può effettuare il test, piuttosto che essere in grado di osservare che venga utilizzato in modo corretto il dispositivo, che sia indossato nella maniera e come previsto dal fabbricante. Deve quindi poi condurre i vari fit test secondo le procedure UNI o secondo le procedure ISO. Deve valutare quindi i risultati, essere in grado di fare il debriefing all'operatore correttamente, quindi spiegando quali sono i dati rilevati dagli strumenti e dalle attrezzature e qual è l'esito finale per il fit test. Logicamente deve essere in grado di identificare quali possono essere le cause di un possibile fallimento, quindi quando il fit test non è andato a buon fine, e oltre ad essere in grado di individuarle deve essere in grado anche di sistemare questi eventuali problemi. Una legata all'allegato A alla norma ISO, definisce quindi quali sono le competenze singole del fit test. In Inghilterra il BSFI ha definito che ormai da anni un metodo di accreditamento per certificare i fit test. Questo metodo è chiamato fit to fit e questo schema di accreditamento è stato acquistato in Italia da Confindustria per conto di Assosistema, che è l'associazione di categoria dei fabbricanti di dispositivi, tra i quali anche gli APVR. È uno schema che quindi accredita la persona come persona competente. Non è un obbligo, perché ricordo in questo caso la norma ISO è una norma volontaria, ma è una modalità per definire se la persona è competente. Quindi diciamo che spetta al datore di lavoro, o meglio al responsabile del programma di gestione del APVR, definire i criteri per selezionare la persona competente. È logico che se prendiamo, passatemi il termine, il primo scappato di casa che passa davanti all'azienda e gli diamo in mano l'esecuzione dei fit test, probabilmente qualcuno potrebbe alzare la mano e in caso di malattie professionali avere qualcosa da ridire. Ecco, io sono stato nei tempi imposti e rimango poi a disposizione per eventuali domande o altro in merito a quello che può essere la normativa.
Ok, io introduco a tutti il fatto che ora Giannina ci presenterà in maniera professionale, profonda e dettagliata il respirator fit testing, che è lo strumento della TSI in grado di eseguire il fit test quantitativo a tutti i tipi di APVR, praticamente a tutti i tipi di APVR presenti sul mercato. Lo strumento snello, intelligente e preciso e accurato, in grado appunto di adattarsi a tutti i settori, a tutti i tipi di respiratori. Sottolineo che anch'io eseguo corsi di formazione, qualcuno di voi che è collegato sicuramente li avrà già seguiti insieme a me, sicuramente ho condiviso con Marco situazioni dove l'abbiamo visto e rivisto assieme, quindi anche qui lasciamo la presentazione di Giannina, che è veramente specializzata ed è veramente puntuale e chiara in tutta la sua descrizione. Per qualunque cosa rimango a disposizione io sia nella chat, e comunque ribadisco che alla fine apriremo il microfono e potremo parlare liberamente alzando la mano e rispondere anche verbalmente alle questioni che vi siete segnati. Ok, non tolgo più nessun secondo a Giannina. 11:19, chiudo il mio microfono e I pass the ball to Giannina Sander.
Okay, thank you. Yes, the same as before. If I'm too fast, just let Alessandro know and he will interrupt me. I will talk a little bit after we heard the theoretic part and the legal part. We will now talk a bit about the practical point of view. So how does respirator fit testing looks in practice? I just wanted to repeat the definition of respirator fit testing. Respirator fit testing is the verification whether a specific tight-fitting respirator can create a tight fit on a wearer's face. So it's about a specific tight-fitting respirators, and it's not about testing this respirator, but it's about testing the fit on a wearer's face. So you can, put the fit test as one part in the individual suitable selection of respiratory protective equipment, and therefore fit testing is a quite small but very important part in occupational health and safety at all. First, I would like to take a look at you on the effects of fit testing that we do see in practice. And we do have 4 effects: safety, comfort, training, and sensitization. And for safety, I show you 2 studies. The first one took a look at the simulated workplace protection factors of N95, so like the pendant to the American pendant to the FFP2 masks. And they took a look at the N95 respirators without fit testing. And the average protection factor that was gained was 3.3. Just for comparison, a surgical mask, which is not a protection mask, and that's an occupational health and safety, got a protection factor of 1.2. And if we take a look at the N95 respirators that passed a fit test using the PortaCount instrument, they got a fit factor of, or a protection factor of 20.5. Another study compared 17, so it was a research literature study. So this study took a look at 17 different studies, and each of the 17 studies took a look at the workplace protection factor. And this graph is a bit complicated because it's logarithmic, and you see on the x-axis the probability that workers fail to achieve the workplace protection factor. And the workplace protection factor is shown here on the y-axis. And they grouped all the results of the 17 different studies and got this one trend for workers who got a fit test and for workers who did not get a fit test. And if we take a look at the red example, it's a protection factor of 10. You do see that there are nearly 50% of people who got not fit tested fail to achieve a protection factor of 10, while from the people who are fit tested, it's just like nearly 2% who do not achieve 10 as a protection factor. If we take a look at the blue example, it's a protection factor of 100. We do see an increase. Even workers who got fit tested, we now have 16% of people do not reach 100. But from the people going on to the line of workers not fit tested, 97% do not get a protection factor of 100. So only 3% do achieve the protection factor of 100. So what does we see? We see that the fit test is not a 100% guarantee that all workers are protected, because the human factors like donning, adjusting, whatever are still decisive. But fit tests and appropriate training lead to significantly higher workplace protection factors, and thus the employees are better protected, and therefore the safety is increased. The second effect of fit testing is training. And the training effect comes with the questions that fit tests clarify. It's not just does this respirator fit? There are questions about, will this respirator fit me in terms of, does the respirator have the right shape for my face? Is the respirator the right size for my face? Does my scars, prominent cheekbones, whatever characteristics affect the tight fit? And the second part, does my donning process fit? So am I putting the respirator on correctly? Do I get a good seal when putting on the respirator? And with all these questions, you have a great training tool with doing fit testing. So, overview of the effects. Safety, we minimize the risk posed by poor fitting personal protective equipment, and in terms of confirming the fit of the respirators. Marco already talked about the comfort. We are checking with the fit test also the comfortability of the respirator, and therefore we are increasing the acceptance to wear the respirator because we are sorting out uncomfortable respirators. we have a training effect, training in the correct donning and use of the respirator, and we are feeling more, or the people feeling more confident and therefore more motivated to wear the respirator as trained. And the fourth effect is like an indirect effect. It's the topic of sensitization, because with doing and talking about this fit testing of respirators, the understanding of the importance and functionality of the respirator increases, and therefore the acceptance of the respirator as a protective device increase with the employees. Okay, that for the effects of fit testing, and now take a look at the methods of fit testing in practice. So how to fit test respirators. Marco already taught there are two general methods, the qualitative fit testing, which is a subjective test, and the quantitative fit testing, which is an objective test. And first the qualitative fit testing. This one is based on the response of the person being tested to a test agent. So you have the person wearing the mask, putting this person into a local test atmosphere. This is normally created by such a hood. And in this local test atmosphere, into this hood, there's a test substance sprayed in. This test substance is bitter or sweet tasting or smelling. And the person who is wearing the mask should subjectively evaluate by sensory recognition if it can taste this substance or not. And because this is very subjective, it's only allowed for disposable and reusable half masks, not for full face masks. And this is, from a technical point, defined as only allowed for masks with a required minimum fit factor from less or equal to 100. The quantitative fit testing, on the other hand, you have the person wearing the mask and connect this person or this mask to a measurement instrument. This measurement instrument then it makes a CNC particle counting and therefore determine particle concentrations inside and outside the mask. And there's also a second technology, the CNP controlled negative pressure method, which makes a pressure and airflow measurement. And quantitative fit testing can be used for all reusable half and full face masks. And if you're using the CNC technology, so the blue one, you can also test disposable masks, so FFP mask, meaning with using the CNC technology, this is the only technology that you can test every respirator, from an FFP1 mask to a full face mask. Every respirator can be tested with the CNC particle counting, and quantitative fit testing in general is allowed for all required minimum fit factors. Okay, so far to the methods of fit testing. And as we are, as TSI, involved with the PortaCount respirator fit tester in quantitative fit testing, I would like to introduce this instrument to you. The PortaCount respirator fit tester is an instrument for quantitative fit testing using the CNC particle counting technology. So it is suitable for all types of tight fitting respirators. So what's the concept of CNC particle counting? Let's take a look back on the first presentation, a person wearing the mask. And if it's a good fitting respirator, we have many hazardous substances outside and a very few inside, while in a poor fitting respirator, we have many hazardous particles outside as well as inside. And the concept is quite easy, because we say with a good fitting respirator, the concentration inside the respirator has to be low, while in a poor fitting respirator, the concentration inside is high. And with this idea, we are talking about the fit factor. So we are measuring the ambient concentration out, and the concentration inside the respirator, C in, and the ratio of this two values gives us the fit factor. And if the difference is quite big, the fit factor gets bigger. And if the concentration are nearly the same because the respirator is poor fitting, the fit factor gets quite low. And therefore, we have two prerequisites. It's one, we need a mask with a good filter. And of course, we do need a sufficient number of particles in the environment. And because we do not want to generate particles all the time, we are taking a look at very specific particle size where we do find this high number needed for the test. I put this picture from the first presentation here as a reminder. So we have 60 micrometer down to 1 micrometer, this green bubble here. And the PortaCount instrument measures particles from 0.02 micrometer up to, oh, sorry, this is still German word, I forgot to translate. This is up to 1 micrometer. So from 20 nanometers to 1 micrometer. And if we take a look at this picture, you remember from the first presentation, this blue box is the measuring range for the PortaCount instrument. And in this size range, you already find millions of these particles, or 1,000 at least, per cubic centimeter in our normal office rooms or whatever. So you can just use the particles that are there, but that we do not see because they are that small. Remember here that we do not see them, that there are so much of them. Okay, I said we are measuring very, very small particles. So how can we measure these small particles if we as humans cannot see them? This can be done by the CNC, condensation nuclei counter, and this is why the method of fit testing is named CNC. This is the instrument or schematic draw of the instrument, and the first part inside the instrument is the saturator. We are getting our samples from the ambient air or the mask. This is a valve, so we are just looking at the mask or the ambient air. And then we are taking this air sample and have that flown through the saturator. In the saturator, alcohol is evaporated to create the supersaturated vapor, and the particles flow through this area, and we get a nice mixture of particles and alcohol vapor. In the next step, we are condensing, so we are cooling the mixture down, and the alcohol vapor starts to condense. And for physical, technical reasons, condensation always starts on surfaces. So what surfaces do we have in the condenser? It's the particle surface. So the alcohol condenses on the particle surface, and therefore we have tiny little droplets that adhere to the particles. And when we go on with the condensation, these droplets form a layer around the particle, and therefore the particles grow. So the particles are enlarged by the alcohol layer. And with further condensation, we do get a small particle as a nuclei within a bigger droplet. And this, bigger droplet, can be detected by a laser detector, and therefore we can count the particles inside the instrument. So far through the PortaCount technology, let's take a look at the practical side. So if you now want to fit test your employees in your company, how are you doing that? At first, there are different fit test protocols. There are 3 most common protocols. In US, the OSHA protocol, which is a law in all US countries, and there's a legacy test protocol and 2 modified shorter test protocols. In UK, you have the HSE INDG protocol. This is also in UK a law, and you have this fit-to-fit compagnon that Marco introduced, this competence scheme for fit testers. And on the international side, you have the ISO 16975/3 standard, which is also a protocol, and this is the focus protocol in Italy. So if you in Italy want to start fit testing now, you should most probably use this ISO protocol. And of course, there are other countries with like France or for asbestos industry or Canada who have also some different standards and protocols, but the 3 above are the most common protocols. And for you, the ISO protocol is the most important. And this is why in the following, I will always refer to this ISO protocol. So when you want to do a fit test, what are the steps you have to do? These are the 7 steps. First, a general preparation. Second, the respirator selection. Third, the installation of a fit test adapter. Then the assess of comfort and tight fit. Afterwards, an instruction or last instruction in the fit test. Then you have to connect the respirator to the instrument. And as a 7th step, conduct the fit test itself. Let's start with the general preparation of the instrument. Of course, you have to start. So you have to check that the unit, and this is written down into the ISO standard, is in a well-maintained, clean and hygienic condition. And of course, you have to set up the device. And I show you in some pictures, it's quite easy. At first, you have to connect the power supply. As a second, you have to connect the instrument to your laptop or tablet you want to use the instrument with. As a third step, you have to connect the tubes. So these ones are the sample tubes you need to connect the instrument to the mask. We have these tubes. There's one side with a clean cut. This one goes to the instrument. And you see on the other side, the blue tube is shorter than the clear tube. The clear tube is the one that will go to the mask, and the blue one therefore is shorter, that it ends a little bit before the mask, that it can still get the ambient air and is not sucked to the mask itself. And the last step of preparation is preparing the alcohol. So the alcohol is nothing the person to be tested has to drink or something like that. The alcohol is just to be used inside the machine. And you have like a sponge alcohol wick that is inside this silver cartridge. You let it soak with alcohol and afterward for 1 or 2 minutes, and afterwards insert it into the instrument. And this is already the setup. As a third step in preparation for the instrument, you have to perform the daily checks. What are the daily checks? The daily checks are a series of tests to verify the functionality of the instrument. And as we do have 2 different modes I didn't talked in general about, there are also 2 sets of this daily check. But if you're interested in that, we can do it afterwards because that's already quite detailed. So why are you doing the daily checks? To ensure the proper function of the PortaCount device and to determine the suitability of the environment you want to fit test in. And therefore, you should do the daily checks every day at the beginning of the fit test, a day, and every time if the fit test location has changed. So if, for example, if you're testing in the morning in conference room A, and after lunch, you're going on with testing in conference room B, you should redo the test to check that the room conditions are perfect as well. The second point of general preparation is the preparation of the room. So you should create a sufficient space that the people can move on. For doing the test, you should ensure that the ambient concentration is high enough. And the recommendation from our side for using the PortaCount would be 2,000 to 8,000 particles per cubic centimeter in the standard mode. And if you're using the N95 mode, 200 to 800 particles. And if necessary, I said normally you have enough particles, but if it should be too less, we are delivering with our instrument a particle generator. So you can use this one to create the right concentration in the ambient air. The last step of the general preparation is the preparation of respirators. Why you have to prepare them? You want to test if the mask fits the person. If the mask fits the person, it's all fine. But if the mask does not fit, you have to have alternatives. So another model, another size, whatever. And this you should have prepared, because if a person fails the test, you are not allowed to send this person back to work with this respirator, because you know that it's not fitting. So be prepared and have alternative respirators, sizes, and other models available, that you can find the respirator that really fits this person. And this one, of course, you should have like laid down in the room before, just to avoid times pendings afterwards. It's better to prepare in the beginning. It just costs a bit of time, but saves you a lot of time during the fit test itself. Afterwards, there comes the respirator selection. And of course, you have the, let's say, the process before, talking about potential hazards, work rate, wearing time, which defines which type of respirator should be worn. During the fit test, you take a look at points like clarity of vision, clarity of communication, mobility, interaction with other PPE, like Marco already said, with glasses, for example. So this is something where you choose the right size and model from the respirator during the fit test. Afterwards, you start with the probing, and ISO standard requires to provide the selected respirator with a sample probe, fit test adapters, and filters. It is important that the air sample is taken from the breathing area, midway between nose and mouth. And there has to be no physical separation from the sampling area. One example here of a half-face mask. This is the mask, this is the connection, and these are the normal P3 or filters outside. For the fit test, you're using a P3 filter element or a US class 100, but in Europe a P3 filter element. And between the filter and the mask, you're putting fit test adapter. And here's a picture of how this adapter looks at practice. This one is a reusable adapter with a connection, tube connection in the outside and in the inside. In the outside, there comes this tube from the instrument later on. And in the inside, you use a short one-use tube that you put from the connection through the valve inside the mask and clip it between nose and mouth in the mask. This is for a reusable mask. For FFP mask, of course, it has to be a little bit different because it's a one-use mask, and therefore we have to also use this metal one-time usage sample probes. And you see here on the picture that we deliver the instrument to probe the FFP mask directly with the instrument. And it's quite easy. You have these two metal parts. You put them into this tool, put the mask in the tool, press it down, and afterwards you have the sample probe within your mask. This is the third step, probing. Afterwards, we came to the fourth step of assess comfort and tight fit. So you have to talk with the person. Is the comfort of the mask acceptable? Do you have any restrictions? Do you already see some health complaints, or do you have some health complaints like skin irritations, allergic reaction, and pressure marks? And it's very important that this last aspect of skin irritations and pressure marks, the operator, the competent person, should also check after the fit test. When the tested person takes off the mask, just check again that there are not, after some minutes, like 1 centimeter big pressure marks. Then you know this person wouldn't wear this mask for some hours. Afterwards comes the fifth step, the instruction. So it's like the redo, be sure that the person knows what will follow. So talk about the goal of the fit test, the procedure of the fit test, what's the task of the person who is tested, and what is the meaning of the result in the end. Then the last step before doing the fit test, connect the mask with the instrument. So you're using this tube, this twin tube, you already connected to the instrument and connected to the mask. You see it here, just connected to the fit test adapter, and then all is fine. If you are using, or if you're testing reusable masks, if you're testing FFP mask, you have to be careful that because FFP mask is quite lightweighted, and the tube, of course, already have its own weight. And you see here that this tube is affecting the fit of the respirator, or how this respirator sits on the face. And therefore you get this necklet with the instrument. This is not for a key or as a nice accessory. This is the tube necklet. This you put around your neck, clip it to the tube, that the weight of the tube is hanging on this collar and not on the mask. And you see here at this part and this part the differences in the sit of the mask. But this is just for FFP mask. For reusable mask, the weight of the mask is higher than of the tubes. Okay. Then we are coming to the last and the most important step, conduct the fit test itself. And I took a look at the ISO standards Marco talked about and what they require. They require the operator has to observe the fit test procedure, the instrument's fit test cycle has to be initiated, and the fit test is completed when all exercises have been completed. So what does that mean in practice? And the best practice to start with is to, which is proven in practice, is to, before starting the fit test cycle itself, check the tight fit via the real-time fit check mode. This is possible with our instrument. There's the real-time mode available. And so you first simply said, okay, don the mask and we just check how it's fit currently. So just simply have the person standing there breathing normally. And if it looks good, you let this person perform each fit test exercise for a few seconds to see if it still looks good, or if you like dropping down into the red area. So that you just start the fit test after you got a good feeling that the fit factor is sufficiently high for all exercises. This practice is a big time saving because you quickly detect if there's a very poor fitting mask, and you can quickly try out different fitting options like, okay, adjust the mask on the nose, tighten the head straps, tighten the lower straps, whatever. And therefore you can repeatedly sorting out masks that are just not the right size, that are just not the right form. So you start the entire fit test only when there's a certain degree of certainty that it will be passed. And this saves a lot of time instead of always start the test, which needs 9 minutes and 20 by standard requirements. And then afterwards, you can start the fit test cycle itself. And that's quite easy because you do get the screen. You're choosing the person you're testing and the mask you're testing. And then this window here will appear on the screen. You just press start. And afterwards, there will be animations shown to you. And the person who is tested just have to follow the movements shown in the animation. And the exercises and the sequence shown are according to the ISO standard. So the operator, the competent person, is free to do other aspects and do not have to, make the movements him or herself, because the tested person needs only to mimic the animation during the test. And After exercise per exercise is done, after the last exercise, you quite easily see directly the result: red, failed, or green, passed. Okay, so I talked a lot about the exercises. What are the exercises in the ISO protocol? We have 7 exercises: normal breathing, deep breathing, turning head side to side, moving head up and down, talking, bending over, and normal breathing. Oh, there's an L missing. So this is normal breathing. So what does the person have to do? The first one is just standing in normal position. Do not talk, just normal breathing. The second one is slow and deep breathing. It should be different pressure that's put on the mask with deeper breathing. To exercise 3 and 4, want to provoke the mask fit by movings of the head. So first side to side and fourth up and down. Afterwards, as a 5th, came the talking. You should talk slowly and loud, that the operator can easily understand the tested person. And for talking, you can read from a prepared text, count backwards from 100, or recite a memorized poem. I always recommend to use a prepared text, because when counting backwards or reciting a poem, you might have their thinking breaks, I call it. I don't know if the wording is correct in English, but so that you like the people stop talking, like remembering, oh, what was the number before 96? Oh yeah, it was 95. So in this small break, they stop talking. And so we have, during the measurement, some seconds where it's not doing the exercise. So it's always better to have them read from a prepared text, because then there's continuous talking without thinking breaks. And also the software will show you a text that can be read out loud. The 6th exercise is bending over. So you're bending over at the waist so that the gravimetric forces are taking on the mask, and you are checking if the mask still fits your face. And the last exercise is again normal breathing. All these exercises should be have a 60-second sampling inside the mask according to the protocol, but this is all pre-programmed in the software, so it's not that you have to stand there with a timer and check that the exercise is performed long enough. This is all pre-programmed within the software. Some words to the evaluation of the fit test. The significance of the results. ISO mentioned that any adjustment after the test started will invalidate the test results. And if you do get an exceptionally high fit factor of, for example, greater than 1000, be careful and check, because it can indicate a problem. For example, if the tube inside the mask is sucked on the person's face or sucked on the mask, then there's no really good sample probe taken. But of course, the fit factor is quite high, because it's like soaking a vacuum. The next point is the overall fit factor, because for every exercise, there's a fit factor calculated or measured. And from all these 7 different fit factors, you are calculating the overall fit factor. And for passing a fit test, the overall fit factor has to be bigger or same as the required minimum fit factor. And ISO requires a fit factor for full face masks of 2000 and for half face mask and FP mask of 100. You do not have to remember this formula, because the software is calculating the fit factor on its own. So you do not have to do it per hand, but the software is doing it automatically. ISO always also points out that if the test fails, you should only allow 3 times of repetition with the same mask, because otherwise it would be some kind of force fitting. So if after the third time or the person still does not pass the fit test with this mask, you should change the mask, like another model or another size, or, and this is also important, check if you can change model or size of interfering PPE. For example, if you have hearing protections or a helmet, check if there can be model or size change, that it's not interacting with the mask's fit. And therefore, I think Marco already said it, during the fit test, this kind of other personal protective equipment has to be worn. So like hearing protection helmets, it has to be worn during the fit test together with a respirator to check if there is this kind of interaction. Okay. Last point, Marco already mentioned it as well, is the documentation. And the nice thing is with the fit test, with the PortaCount, that the documentation is automatically done with the software. So you have the name of the tested person. You have the test date on the example report. You have the identification of the respiratory protective equipment. You do have the identification of the operator. You do find notes like other PPE worn, corrective actions, additional information. You do find the indication of test equipment, the pass level that was used, the results that were received, also the overall fit factor that's received, and the method that is used. And with that, this was how to fit test respirators with a PortaCount. And I think, Alessandro, that we are now going on to the questions.